Hi guys, so today we're going to continue on with parallel and perpendicular slopes. I'm actually going to go back that one step and just a couple reminders. For parallel lines, when we're finding their slopes are exactly the same. It's not focusing nicely. There we go. So if you said the slope of one line is 2/3 and you want the slope of a line parallel, it's the exact same. Slopes of perpendicular lines are opposite reciprocals, meaning that you take the fraction, you flip it, and you change the sign. So we did the other day, just like, all right, if you got a slope, what is the parallel or perpendicular? And we talked about maybe graphing some of them. Now what we're going to do today with it is, what if I'm given an equation, a linear function that is in usually standard form. Let's say I have like 2x plus 3y equals 7. And I want to find, we're going to do all three. The parallel slope and the regular slope, whatever the slope of this line is. What would the slope of a parallel line be? What would the slope of a perpendicular line be? I should have put these over here, so I'll rewrite this here. 2x plus 3y equals 7. So in order to find the slope, my first step is I want to put into slope intercept form. So to do that, you solve for y. I subtract 2x. I get 3y equals negative 2x plus 7. Divide everything by 3. And you could simplify if it's there. This one can't. There's your slope. You don't have to, don't worry about even rewriting this. Okay, you could, I should say, go maybe here, y equals 2/3 x plus 7/3. But all we need is this here. That's our slope. Negative 2/3. And then the second part is, all right, now let's find a parallel slope. Exact same, negative 2/3. Let's find the slope of the perpendicular line would be the opposite reciprocal. So the opposite of a negative is a positive. The reciprocal would be take the fraction and flip it, would be 3/2. Okay, so I took a line, just put it in slope-intercept form. Why slope-intercept? Because it tells you the slope. Okay. All right, let's take a look at another one like that. Now, I should say on your homework things or on your classwork, it's going to ask you just for one or the other, but we're doing all three or all two, the parallel and perpendicular, just because it's there. All right, let's say we have 5x minus 7y equals 14. So that first part, I need the slope. Once I have the slope, I can find the parallel and perpendicular. I need to solve for y. So we did some of this when we were putting things. We've done a lot of this actually, solving to put things into slope-intercept form. So if I want to get y by itself, I then need to divide everything by negative 7. So I get y equals, here the two negatives become positive. 5/7 is just that. It doesn't simplify. 14 divided by 7 is negative 2. And if you screw that part up, for these, it doesn't matter because that's what I want, the slope. So in this case, the slope is 5/7. A parallel line slope would be 5/7, exactly the same. A perpendicular line slope changes the sign, that's opposite. So positive becomes negative. Reciprocal is flip it. So 5/7 becomes 7/5. Okay. Now, for the other set of problems here, it's the same idea, except instead of just getting the slope, I'm going to want to put this slope then into an equation. Well, how do I do that? I'm going to need another point. So here's what these are going to look like. It'll say, okay, if I have 3x plus 3y is equal to 12, I want to find the line, or I want to be able to write a line that is, let's say, perpendicular, and I'm shortening up some of the language, goes through the point 7, -4. Well, let's think about what we need to do. First, we need just the slope of this line. How do we do that? We put that into slope-intercept form. So I'm going to solve for y. Subtract 3x. So I have 3y equals -3x plus 12. Then we divide everything by 3. So negative 3 divided by 3 is negative 1x. Now, would you normally put it there? No, but I know I'm trying to pull the slope from there. So I'm saying, all right, the slope of this line is negative 1. Now, here we just need the perpendicular slope. So the first thing we did, we found the slope of this line is negative 1. Now I need the slope of a line perpendicular to it. But you might say, okay, the opposite of negative is positive, but how do I flip 1? Well, think of it like a fraction, 1 over 1. How do you flip 1 over 1? It's still 1 over 1. So the slope of that perpendicular line would be just 1. So let's think through that process again. Opposite, negative to positive, flip 1 over 1. And for that one, it just happens to stay the same as 1 over 1. That will happen sometimes. That's okay. All right, so now I have the perpendicular slope. I know that slope is 1, goes through 7, 4. Well, this is why point slope form is so helpful. You have a point, you have a slope. So we're going to put it into that form just as a reminder what point slope form is. Y minus y1 equals m times x minus x1. Y and x are never going to change. So these two stay as they are. We're plugging in for m. In this case, it's 1. I'm leaving the x minus the x coordinate here is 7. I'm going to go back. Y minus the y coordinate is negative 4. Well, the negative of negative 4, clean it up, turns to a positive. So I get y plus 4 equals. Do I need this 1? No, I don't really. I could just go to x minus 7. So this one, I kind of got all the special case things out of there. What if you get a slope of 1 or negative 1? What's the opposite reciprocal? Well, change the sign, flip 1 over 1, it's still 1. What if you get it here where you put in 1 and you don't need the parentheses really? Well, then don't write them. You could just put y plus 4 equals x minus 7. Okay. All right, let's take a look at one more like that. So what we have again is we start with an equation. Let's say I have 4x minus 3y equals 12. And I wanted to find, I'll do perpendicular just because it does more. So a perpendicular line that goes through the point 3, negative 2. I'm going to make it negative 3, negative 2. So step 1, put in slope-intercept form. I need the slope. So I'm solving for y. I'm going to subtract 4x to start and add 12. Divide everything by negative 3. So y equals the two negatives turn to a positive 4/3 x. 12 divided by negative 3 is negative 4. So what's this line slope? Well, it's whatever's in front of x, 4/3. What would a perpendicular line slope be? Well, it'd be opposite. So it was positive, it goes to negative. And flip 4/3, that's reciprocal to 3/4. So now I have the two things I need, a slope and a point to put it into point slope form. So I have y minus the y coordinate here, there's our y1 if you want to label, is negative 2 equals the slope is negative 3/4. I'm using this line now. I have a new line that's perpendicular to it. Once I got the slope here, I'm done. I find the perpendicular line or the parallel line slope. That's it. And then I take x minus the x coordinate is negative 3. So all I got to do here is some cleaning up. Two negatives multiplied give us y plus 2. We have negative 3/4 here. X, negative and negative, gives us plus 3. And we can leave our answer like that. You don't have to put it into slope-intercept. You don't have to put it into standard. They just said find the equation of a line that goes through this one that's perpendicular to the other one. Okay, well then let's use point slope form to help us out and make it a little bit easier for us. Okay, so there we go. We know what we have to do with it. It really comes down to step 1, putting those into slope-intercept form to find the slope. Step 2, find the parallel line slope, which is the same, or a perpendicular line slope, which is the opposite reciprocal. Once you have that, if it's one of these problems, you have a point, you put it into point slope form. Bada bing, bada boom, you're done. All right, great job, everyone. See you next time.